All right, welcome to lesson 5.1. So we're going to start chapter 5 here. In chapter 5, it gets into three-dimensional figures. And we're going to do measurements within three-dimensional figures. So we're going to kind of bounce back to unit 2 and unit 3 when we talked about measurements, but we're going to do everything three-dimensional. That means three-dimensional Pythagorean theorem, three-dimensional distance formula, three-dimensional measurements like perimeter and area. But first, we need to establish some ideas about three dimensions. All right, so a polyhedron is a fancy word for a three-dimensional polygon. Meaning all the sides are made up of polygons. And we can classify those parts of the polyhedron, so this is a polyhedron, with words like a face, an edge, and a vertex. So a face is any side. So it doesn't have to be top, bottom, left, right, front, and back. It's basically any of the surfaces, if you want to consider them walls or ceilings or floors. Basically, a face is any side. And again, any of those sides will be a polygon. So I don't like to just color in the top because you might think, well, the top is the face. No, I can color in the front, the sides. So if that was a room, all the walls, the ceiling, and the floor. An edge are like the corners of the room. It's where the faces meet. So where two faces or sides meet. And then a vertex are the corners where the edges meet. And we're really just going to bounce around between those three ideas today. So we're not going to go all the way through lesson 5.1. We're just going to get an idea of the relationship between faces, edges, and the vertices. So while polyhedron is just a general version, just like a polygon is, we can get more specific and we can say prisms and pyramids. Now, hopefully you guys all know what a pyramid looks like, whether it's a pyramid in Egypt. A pyramid comes to a point. So it has a base, but that base that's on the bottom doesn't exist on the top. So all the sides fall together to a singular point. And that's what makes it a pyramid. They come to that common vertex. And I know I'm kind of doing this backwards here, but pyramid tends to be one that we're more familiar with. A prism, we have that same triangular base. It doesn't have to be triangular. It could be rectangular. It could be a pentagon. It could be a square. But the idea that it also has the same exact base above it. So think of your bedroom. You have the floor and you have the ceiling. They're the same. That's what makes it a prism. You have two parallel congruent faces called bases. Now, as we move on, bases do not always have to be on the top and bottom. They always have to be congruent and parallel, though. So the idea of being congruent and parallel is more important than top and bottom. You'll probably choose the top and bottom. It's more instinctive, but sometimes I will not, just to make you feel a little bit unnatural with the idea of what a base is. All right, classify each figure, name the vertices, the edges, and the bases. So is it a pyramid or is it a prism? Well, do we have two bases or one base? There's a base, and there's a base. So this is a prism. Now, like I said, it doesn't have to be the top and bottom. Maybe the bases are on the left and the right. Okay, maybe that box got pushed over and the true top and bottom is now on the left and right. Or maybe it's in the front and the back. It's a little hard to shade that in. As long as there's two, they're parallel and they're congruent, then you got yourself two bases. All right, name the vertices, the edges, and the bases. Let's do bases first, since we just talked about them. So the bases, they're two rectangles, A, B, C, D, and E, F, G, H. The vertices, A, B, C, D, E, F, G, H. Remember, they're just the corners. The edges, we have AB, we have BC, we have CD, we have AD, we have EF, we have we have FG, we have GH, we have EH, we have AE, we have DH, we have CG, we have BF. It's going to be more important to be able to count them than to name them, but naming them is going to help us identify them here early on. Really, we're going to want to be able to count them. All right, classify each figure. Okay, is this a pyramid or a prism? Okay, here's a base down here. It's a pentagon. And we only have this singular point here, so that makes it a pyramid. And I'm just going to talk through them this time. The vertices, A, B, C, D, and E, and F. The edges, A, B, B, C, C, D, D, E, and A, E, and then A, F, B, F, C, F, D, F, and E, F. And then the bases, We only have one. The base would be A, B, C, D, E. All right, Euler's formula. This is going to be the big formula right out of the gate that we're going to use. So vertices, edges, and faces. So if you add up the number of faces and the number of vertices, that will equal the amount of edges plus 2 more. So let's see how that plays out. So how many faces vertices and edges? All right, the amount of faces, remember the faces are all the touchable surfaces, all the polygons. So it's all the walls, the ceilings, and the floors. So the walls and the 2 bases. In this case, it's a prism. We have 2 bases, so that's 1, 2. And then how many walls do we have going around? Well, there's going to be 1 wall for each side of the base, and that's how I count them. So 1, 2, 3, 4, 5, 6, and then a top and a bottom. So 6, 7, 8. How many vertices? 1, 2, 3, 4, 5, 6 up top, 6 below. That's 12. How many edges? Well, we have 1, 2, 3, 4. So we have 6 going around, another 6 going around. That's 12. And then 6 connecting. So that's 18. So 8 plus 12 equals 18 plus 2. Two. How many faces? Well, we have a bottom, and then we have 4 triangles going around. So that's 5 faces. Vertices, we have 1, 2, 3, 4. We have 5 vertices. And edges. Edges, we have 1, 2, 3, 4, 5, 6, 7, 8. So 5 plus 5, which is 10, equals 8 plus 2. That's always going to be a plus 2. That doesn't change. And that's all we're going to do for today. Here's some practice problems before you guys do homework. So hold off on the homework. Try these practice problems. They're actually going to be the exit ticket as well. But just practice them. You have a front and a back here. Notice it goes straight to the rest of the notes. And then the homework, since I wasn't able to make these booklets in the building, these are the booklets from last year. The homework is at the very end of the entire booklet. So all the homeworks are in the back with the review. All the note packets are up front. So you have to go to the very end to find the homework. But I don't want you guys to go any further than that. Don't go past this page. Don't even do this page yet. You're going to stop right here on page 4. Okay, so try that in-class practice today. do the exit ticket, office hours if you want to talk about the exit ticket, and then tomorrow's lesson we'll finish out these notes, and then you can do the homework. Okay? Make sure you guys get in touch with me with any questions.